A quadrilateral has these properties. The diagonals are the only lines of symmetry. It has rotational symmetry of order 2. Write down the mathematical name of this quadrilateral. Here, even though this is just a 1 mark question, I'm going to explain in detail about symmetry. Here, it's about a quadrilateral. You should know what a quadrilateral means. A quadrilateral means it is a four-sided polygon. It has four sides. So there are six types of quadrilaterals, six different types of quadrilaterals. So let's just name them down here, starting with a rectangle. Rectangle is a quadrilateral because it has four sides. Then we have square and parallelogram, rhombus, trapezium or trapezoid, and we have finally kite. So first I'm going to discuss about the line of symmetry, and then we will move on to rotational symmetry. So I'm just going to draw all the six different shapes here. Rectangle. I'm not using a scale here. It's just a rough sketch. Rectangle. We have a square, and then we have a parallelogram. Then we have a rhombus. Rhombus is a parallelogram with all the sides equal. That is the definition for rhombus. Rhombus is a parallelogram, same like a parallelogram, but it has all the four sides equal. And then we have a trapezium or trapezoid. Here I'm going to take a isosceles trapezium or isosceles trapezoid. Isosceles means these two sides will be equal. For example, if this is A, B, C, D, AB and CD. If these two sides are equal, we say that it is an isosceles trapezium. And we have a kite. So now we are going to discuss about line of symmetry first of all for all these six quadrilaterals. Line of symmetry means if we draw a straight line, when we draw a straight line, if it divides the shape into two equal parts, then we say that it is a line of symmetry. For example, let's consider the rectangle here. So for rectangle, if we draw a straight line like this, if we draw a vertical line, it divides the rectangle into two equal parts. So here, a vertical line, a vertical line is a line of symmetry for a rectangle because it divides the rectangle into two equal parts. Now, if we draw a horizontal line here for a rectangle, horizontal line, this horizontal line divides the rectangle into two equal parts, that is top and bottom. So, horizontal line is also a line of symmetry here. Now, if we draw a diagonal here, this diagonal is not a line of symmetry. This is a common misconception. Students used to tend to write this diagonal also as a line of symmetry, but diagonal is not a line of symmetry for a rectangle. If you want to check this, just cut a piece of paper in the shape of a rectangle and fold it using the diagonal. Fold it using the diagonal. You can see that it will not, both the sides will not fit into each other. Or cut as a diagonal, place it on top of each other. You will see that it does not fit into each other. So the diagonals, both the diagonals of a rectangle is not a line of symmetry. So we have only two line of symmetry for a rectangle, that is vertical line and a horizontal line. But when it comes to square, we have four lines of symmetry. That is, a vertical line is a line of symmetry. It divides the square into two equal parts. Horizontal line, yes, it is also a line of symmetry because it divides the top and bottom into two equal parts. And if you draw a diagonal, yes, the diagonal will divide the square into two equal parts. One more, the other diagonal will also divide the square into two equal parts. So for a square, it will, there are four lines of symmetry. Here, we can just write, we have two lines of symmetry here. We have four lines of symmetry. Now coming to parallelogram, it's a very important question. I have seen multiple times they have asked the question line of symmetry to find the line of symmetry for a parallelogram. Parallelogram unfortunately does not have any line of symmetry, which means that if we draw a vertical line, it does not divide the parallelogram into two equal parts. Or if you draw a horizontal line, still, if you have any doubt, you can just make a parallelogram, fold it as using a horizontal line, or cut it using a horizontal line through the horizontal line. Check if both of them are fitting into each other. Place it one on top of the other. It will not. And the diagonals are also not a line of symmetry for parallelogram. Therefore, a parallelogram has zero lines of symmetry. It has zero lines of symmetry. Now coming to rhombus, it has two lines of symmetry, and those two lines of symmetry are the diagonals. If you draw a vertical line, no, it does not divide the rhombus into two equal parts. If you draw a horizontal line, that also will not divide the rhombus into two equal parts. So for rhombus, there are only two lines of symmetry. That is, if we draw a diagonal and the other diagonal, they both will divide this rhombus into two equal parts. If you draw a line, a diagonal line, it divides the rhombus into two equal parts. So here, for a rhombus, we have two lines of symmetry and they both are the diagonals. The trapezium which I have considered here is an isosceles trapezium. In the beginning of this video, I have already explained what an isosceles trapezium is. If you have these two sides equal, AB and CD equal, we call them as isosceles trapezium. So isosceles trapezium has only one line of symmetry. That is, if you draw a straight line, a vertical line, which will give you a line of symmetry. So here we have one line of symmetry. Now for kite, which is the last quadrilateral that we are going to discuss, also has only one line of symmetry, which is nothing but draw a vertical line. So this vertical line will divide this kite into two equal parts. So these are the details about lines of symmetry for the quadrilaterals. Rectangle has two lines of symmetry. Square has four lines of symmetry. Parallelogram 0. Rhombus 2. Isosceles trapezium 1. If it's a normal trapezium, then it doesn't have any line of symmetry. And for a kite, again, it has one lines of symmetry. Now, with these details itself, we will be able to understand the answer. No, it's mentioned that the diagonals are the only lines of symmetry. So here you can see the diagonals are the only lines of symmetry, which means it is rhombus. Parallelogram does not have any. Square has diagonals. Along with the diagonal, we have vertical and horizontal. So that it can't be, because the diagonals are the only lines of symmetry. A rectangle, it has a vertical and a horizontal. It does not have diagonal. Trapezium, it has only a vertical line. For kite, it can be considered as diagonal, but it has one more diagonal. That particular, if you draw a line like this is also a diagonal, but that diagonal will not divide the kite into two equal parts. So the answer should be rhombus. But also one more property is mentioned here, that is, it has rotational symmetry of order 2. Now let's discuss about the rotational symmetry for all these six quadrilaterals. Okay, first of all, let's understand what rotational symmetry means. Rotational symmetry means when we rotate a shape through 360 degrees, how many times we are getting the exact shape. I'll show you an example. Let's say this is a rectangle here. This is a rectangle here. Now, if I rotate it through 90 degree, if I rotate this rectangle through 90 degree, I'm going to get a shape like this. Are these two shapes the same? No. Now, if I am rotating the same shape, the original rectangle, to 180 degrees, to 180 degrees, this is for 90 degree. For 180 degrees, I'll be getting the same shape of this rectangle. So this is once. Now, if I rotate the original rectangle shape into 270 degrees, now I'll be getting a shape like this. Are they both the same shape? No, they both are different. So now 270 degrees? No. Now if I rotate it back to 360 degrees, it will come back to its original position. It will come back to its original position. So this is 360 degrees. So this is the second time I'm getting the same shape when I rotate it through 360 degrees. 90, 180, 270, 360. From 0 to 90, 90 to 180, 180 to 270, 270 to 360. When I rotate it through 360 degrees, how many times am I getting the exact same shape? That is 2 times. Therefore, rotational symmetry for a rectangle is 2. Now for a square, if you rotate it 90, 180, 270 and 360, we will be getting 4 times the same shape. Therefore, we say that the rotational symmetry or order of rotation, same rotational symmetry or order of rotation for a square will be 4. Parallelogram, if we rotate a parallelogram through 90 degrees, 180, 270 and 360, parallelogram will be the same, we'll be getting the same shape once we rotate it to 180 degrees and 360 degrees. Same as the case of a rectangle. When it reaches 180 degrees and 360 degrees, we will be having the same shape. Therefore, a parallelogram will have 2 rotational symmetry or order of rotation. A rhombus. Rhombus, again, same like parallelogram as I have mentioned in previous videos as well. A rhombus is what? Rhombus is a parallelogram with all the 4 sides equal. So rhombus also, when we rotate it to 180 degree and 360 degrees, you will be getting same shape. Therefore, 2 rotational symmetry. Don't think that rhombus has 4 rotational symmetry. No, rhombus we will be getting the same shape only when we rotate it to 180 and 360. Therefore, rhombus will have 2 rotational symmetry. And isosceles trapezium, when we rotate it 90, we will not get the same shape. 180, no. 270, no. 360, when it comes back to one full cycle, when it comes back to 360 degrees, we will be getting the same shape when it comes back to its original position. When we rotate it through 360 degrees, then only we will be getting the same shape. There is no rotational symmetry, or we say order of rotation is 1. No rotational symmetry, no rotational symmetry, but non-rotational symmetry, when we say in terms of order of rotation, is 1. Non-rotational symmetry means order of rotation is 1. Same thing happens for kite as well. Kite, when we rotate it 90 degree, no, not the exact same shape. 180, no. 270, no. When it comes back to its original position, when we rotate it 360 degrees, when it completes a full cycle, we will get the same shape. So for a kite also, we say the order of rotation is 1. We say that it has no rotational symmetry. If there is no rotational symmetry, it has the order 1. For the remaining things, order of rotation, and for example, for a rectangle, order of rotation is 2, rotational symmetry is also 2. For square, order of rotation is 4, rotational symmetry is 4. Only the exceptional cases for if you have no rotational symmetry. If it completes a full cycle to get the same shape, we say no rotational symmetry or it has order of rotation 1. That is the case for a trapezium and a kite. Now let's come back to the question here. A quadrilateral has these properties. The diagonals are the only line of symmetry. We saw when we discussed about line of symmetry, it was a rhombus. Diagonals are the only lines of symmetry and it has rotational symmetry of order 2. So we know that the rotational symmetry of a rhombus is order 2 because at 180 degrees and 360 degrees, we will be getting the exact same shape. So I hope you have understood the whole symmetry portion here. That's about a line of symmetry and rotational symmetry. If you have any doubt, feel free to write it in the comment box. Thank you for watching.